Hello and welcome back to the video series on Advanced Database Management System. This is Kiran Shinde, Assistant Professor at ICMR MC. In my last video lecture, we discussed about the log-based recovery technique. Now in this video session, we are going to talk on deferred database modification process. So let's start. So there are two approaches for log-based recovery, deferred database and immediate database modification. In this video lecture, we will talk on what do you mean by deferred database. And in the next video lecture, we are going to talk on the immediate database modification technique. So what is deferred database? It's nothing but a technique which ensures transaction atomicity by recording all the database modifications in the log, but deferring or postponing the execution of all the write operations of a transaction until the transaction partially commits. Now here, first of all, you need to understand that what technique is used here. The core technique is postponing the write operations. Now, till what we are postponing the write operation in this technique? Until the transaction partially commits. And what do you mean by partially commit? When the transaction reaches to its last instruction or the last statement, then we say that the transaction has entered into the partially commit mode. Once it executes that final statement or the final instruction, then we say that the transaction has been committed and the modifications have been stored into the database. So that is the difference between partially commit and commit. We will try to understand with an example also. A transaction is said to be partially committed once the final statement of the transaction has been executed. This statement or this technique assumes that transactions execute serially. Now, in this technique, we are assuming that the transactions are executing serially. When a transaction partially commits, the information on the log associated with the transaction is used in executing the deferred writes. Since a failure may occur while the updating or the updation is taking place, we must ensure that prior to the start of these updates, all the log records are written onto the stable storage that we have already discussed in my last video lecture also. Once they have been written onto the stable storage, actual updating takes place and the transaction enters into the committed state. Observe that only the new values of the data item is required by this technique. Why? Because it is stored all the modifications onto the stable storage. So what it is actually preserving? It is preserving the new value of the data item. Thus, we can simply use the general update log record structure by omitting the old values. Means here, in this particular technique, the major focus is on redo operation. Okay, so we will see that. Let us try to see an example, a banking example. Let T0 be a transaction that transfers $50 from account A to account B. So the example will be seen in the form of transaction like this. T0 transaction transferring $50 from account A to account B. And you can see here, let TI be a transaction that withdraws another transaction that withdraws $100 from account C. Okay, so these are the two transactions. Now we will see how the log records are written with respect to these two transactions. Let us have a look. Suppose that these transactions are executed serially. Obviously, this is the assumption which we have made at the beginning of our recovery video lecture. So here also we are continuing with the same assumption. So the order which is considered in this example is T0 followed by TI or T1. And that the values of accounts A, B, and C before the execution took place, where account A balance was $1,000, account B balance was $2,000, and account C balance was $700, respectively. The portion of the log containing the relevant information on these transactions is represented as follows. Means how and what will be the actual log records. Those will get generated out after the execution of these two transactions. Let us have a look. So for T0, you can see these are the log records, the start log record, then you can see update log record with the new value only. As I told you at the beginning, this is deferred database modification technique, which is focusing on the new value of the data item. You can see one more update log record with again new value of data item B. Then you can see a commit record. Then this is nothing but the log record. These are the log records for T1 transaction, T1 start record. Then again data item C with the new value because initial balance was 700. So after this operation took place, C has become 600. So this is the new value of data item C and then the commit log record. So these are the log records which will be maintained with respect to these two transactions by making use of deferred database modification technique. But how it will be used when a failure happens or when a failure occurs? There are various orders in which actual output can take place to both the database system. It can be either T0 followed by T1 or it can be T1 followed by T0. One such order which is represented here is, note that the value of A is changed in the database only after the record T0A950 has been placed. What do you mean by this? Since it is deferred database modification technique, means here we are postponing the write. How are we postponing the write? After the modification on that data item has done. So here the new value is getting reflected in the update log record, and after that the write operation will be done here. So that after this the modification will take place in the database. That is why it is called as deferred database modification technique. Now, what will be the use of this? Of course, if at all the failure happens or failure occurs, first of all, it will be checked whether the transaction is preserving the consistent value of the data item or not. And then only the database will be updated. Using the log, system can handle any failure. Let us try to understand these failures with three different scenarios. The recovery scheme will undergo this procedure. Steps are written here and then we will discuss the examples also. Redo TI. Now, what is redo operation? It will set the value of all the data items updated by transaction TI to the new values. Redo operation must be unchanged. Means it should be idempotent. That is, executing it several times, it should be equivalent to executing it once. Means it should not change the values again and again. This characteristic is required if we have to guarantee correct behavior, even if a failure occurs during the recovery process. If suppose the failure occurs after a failure has occurred, the recovery subsystem consults the log to determine which transactions needs to be redone. Now, how to identify that which transaction should be redone? Let us try to understand with an example. Transaction TI needs to be redone if and only if the log contains both the records, TI start and TI commit. So what is the takeaway? If at all you have to make a decision by looking at various transaction logs in your database system, then you have to check for that particular transaction if both the records exist, start and commit record. If both the records exist, then you can decide to redo that particular transaction. Let us try to understand this with three scenarios. Scenario number one. Suppose, now just take this particular figure in front of you. Suppose system crashes before the completion of the transaction so that we can see how the recovery technique restores the database to a consistent state. Now we will assume three scenarios by considering various locations, or I can say various points at which the crash has occurred. Okay. Now this is the first scenario. Assume that the crash has occurred just after the log record for the step write B of transaction T0 has been written to stable storage. Now, what will be the log record for write B? This is the identifier of the transaction, data item, and the new value, because it is performing only redo. Okay, so this will be the update log record for write B. Now, log at the time of crash is as in the figure A. How the system will get recovered from this kind of failure or crash? When the system comes back, it will see the log record and cross-check whether the redo action is required or not. Now here if you see, there is T0 start record, but T0 commit record is missing because crash has occurred just before the T0 actually committed, right? So after observing this log record, what system will see, since no commit record appears in the log, values of account A and B will remain unchanged. So here, no redo operation will take place. So when this T0 will roll back or when this T0 will get restarted, it will again take the original values of account A and B. So ultimately, it is preserving what? Atomicity of the transaction. Scenario number 2. Now let us try to look at this figure. Now assume that the crash has occurred just after the log record of the step write C of transaction T1. Now we are considering that, okay, T0 has committed and now T1 has started, but before T1 commits, the crash has occurred, and hence after write C, the crash has occurred. So you can see this update log record with respect to write C operation. Now again, the log records will be scanned, and when system will look at these log records after coming back out of crash, what it will predict? It will look at T0 and it will look at T1. T0 start record is there, T0 commit record is also there. So what system will do? System will redo T0 so that it will preserve the new values of T0 with respect to data items A and B. And when it will look at transaction T1, it will undo, or rather, we have not come across undo operation yet. So what it will do? It will try to roll back transaction T1 and it will start the transaction T1 with the original value of C. Okay, so this is how system will recover from the crash by looking at the log. Last scenario, if you see this scenario, you will find it very easy with this particular figure. Again, assume that if the system has crashed and it has crashed just after the log record T1 commit is written to the stable storage. Okay, after this, suppose the system has crashed. Again, the log record will be scanned after the system comes back up. It will look at the start and commit record of both the transaction. Now, in this case, T0 start and T0 commit is there. T1 start and T1 commit is there. So obviously, what decision system will make? It will use this deferred database modification technique to apply redo operation on both these transactions, that is T0 and T1. And ultimately, it will preserve the consistency and atomicity of the transaction. So with respect to these 3 scenarios, I tried to make you understand how deferred database modification technique works. Hope you understood it. Thank you for watching.